Okay, so let's keep this going. I want to keep this rocking out here. I like where this is going. Need to get that over here. We might actually even need Tomcat. Let's get him back in here. So obviously that's our fuzz, right? That's what we don't know. It's coming in here, firing ones and zeros at us later. On there, you know, you gotta hang. No, you gotta hang in there, kitten. Stay motivated. Carl Sagan Universe loaf this thing firing at you on the farm. You know, do stuff, squeak for me. Heat, light, and sound. Yeah, you're chasing rabbits around. But at any rate, I'll do this. Okay. So we want to keep this moving, keep it motivated.
The quantum event around the scattering is a mystery. There are literally infinite ways that scattering could have occurred. In fact, according to some interpretations, all infinite intermediate events that lead to the same final result
important for what we're about to do
actually do happen.
What this looks like,
Sort
or
of.
if you...
We talked about this weirdness when we discussed the Feynman path integral recently. Just as with the path integral, to perfectly calculate the scattering of two electrons, we need to add up all of the ways the electrons can be scattered. And this is where Feynman diagrams start to come in handy, because they keep track of the different families of possibilities. For example, the electrons might exchange just a single virtual photon, but they might also exchange 2 or 3 or more. The electrons might also emit and reabsorb a virtual photon, or...
Okay, so they might emit. This thing is the wave function from this quadrant, right? You know, we're saying, well, that's what it's emitting. Or it's going to say from the anti-position of that here, when this and this is a photon, and that's one of the types of reaction it can do that, but it can do it from positionary here. Remember, what we're doing is we're click, click, we're actually sending something up the pipes this way, not here. This is how we test those reactions, right? You know, it's either going to be this one and this one because the photon's coming in or it's going out, and then so to switch over levels, that's what this is about, but that's going to have a result over here. And when you think about why this to this and this whole platform being the reaction, the fuzz in between two of them, or why it works to just say, all right, so that's this reaction, right? Or, well, because it's always starting from the bottom, remember, because we're going time works this way, time works this way, space works this way. If it was just me on the wire walking down the road, it's fine. If I have to do that juggling chainsaws, obviously that changes things a little bit, and it's still this, but moving in that direction. Space is going to be often this direction, right? You know, so now we're shooting something up here. Basically, before these were done, we're just going to shoot a reaction, and that's going to be a particle, something with the charge of we loaded it up and shot it down the pipes where it goes ones and zeros, and you got to be careful with what actual visual light is, which is a computer output about that thing that goes to a particle proton anti-proton collision that can come back down into a photon. Like that thing skipped out and broke into a quantum breakdown. I moved this piece on the chessboard, and that's what I did. I shot it up there. The light on that was somebody like, whoa, you know, and then that's, you know, it emitted a photon and changed into an electron, right? You know, it went through here, gave it its charge, left through here, come out a neutron, and it's going to come out a proton over here, but also a neutron over here. The value is what I want in the positive direction on the math, from the negative negative column, the negative positive column, the positive positive column, and the positive negative value. And that should keep me on a timeline, right? Should give me the photon, gluon, W boson, and Z boson, and still fall to the singularity of charge. Still just positive charge and negative charge to Penrose's on this wire infinitely of the spectrum of particles from gamma, or from, excuse me, photon to gamma, involving all the elements, because we use the visible elements and they're in phase order with each other. They'd be on that connection here, and in the fuzz, we are in the fuzz. So again, I don't know if you can line those up in reactions, but I'd imagine if you're traveling something down the pipes, it's about what's on the right-hand rule of magnets, their charge, their field states, whatever kind of reactionary model at the subatomic level when you just nip this thing off and say that's that reaction, and it's actually happening without this, but because of that, it's a fundamental of this type of reaction. Maybe I want a neutron, maybe I don't. Maybe that at that level, when I put that off into a jar and make a collision with something else, is still going to do this, but the reaction will be 0 to 1. It'll be a decay state in a time. It's like, well, these are particles. They don't like to last long. So what do? You increase time by shooting it down the pipes with magnetic fields that contain that problem in heat and light. And so that stretches out the time on a reaction, right? It says that photon, electron, anti-electron, IGH, so on and so forth, applied to just me walking in the stone mill or playing it from this axion as a piece, this being the base mechanics to standard physics in a whole. Let's call it mathematics and psychology, but mathematics and physics. Radio, we'll say, if we're going to do it like that, it'd be like radio to light, or well, excuse me, light to radio, and then radio to microwave. And I have a photon that describes that, actually. And this can also be light, but it has to be orientated in the correct system. So you'd say radio, 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 microwave, ultraviolet, starting with light across the board, because it would go radio, ultraviolet into a matrix of 3 that defines that. From light you get UV, radio, microwave, light, UV, X-ray, gamma. So there's your 6 base structures of, again, well, what would be this one? I don't know the reaction yet, because this is a more defined model of needing one of these forms to describe that trip over in the 7th phase of orders of magnitude, and will be first order, second order, third order, periodic table. Those types of reactions at the building brick level, where all of those possible reactions could potentially be known, needs to be broken down to things like a standard model. What is up? This first one. This is what I had to work with. What's the bottom limit on that based on the entropy of what it could be made up in the parts of in that system? So you can't forget that that's a technique. That's a field theory. You bring that to the table when it's like, oh damn, the dike gave out and I gotta stick my pinky in it, hold it up over here and put my foot on it every day in the stone mill. Now damn it. Alright, so catch you on the next one.